Hi, this is Andrew Dunkley and welcome to another edition of Astronomy Daily. I'm sitting in for my brother Steve. He and Hallie have gone ring shopping. Not the kind of ring you're thinking about, I'm sure. It's got something to do with Saturn and a story coming up soon. No, Steve's off because of work commitments and asked me to step in for a little while. So I'll be looking after this episode. Coming up, we're going to look at the Viper. That's to do with the Viper Moon Rover. NASA is looking for help. The James Webb Space Telescope is looking at black holes. NASA is sending balloons up, and JUICE is about to fly past Earth, headed for the outer reaches, but it has to go in before it goes out. And we'll be talking to Professor Fred Watson about the rediscovery of phosphine in the atmosphere of Venus.
Astronomy Daily, the podcast, with your host, Andrew Dunkley.
So let's begin with NASA, and as a part of its ongoing commitment to a sustainable and comprehensive lunar exploration program, NASA's issued a request for information to gauge interest from US companies and institutions in conducting a mission using the Viper Moon Rover. Viper, which stands for Volatiles Investigating Polar Exploration Rover, was originally designed to map potential off-planet resources such as ice at the moon's south pole. Now, on the 17th of July, NASA announced plans to discontinue Viper and explore alternative methods for confirming the presence of frozen water around the lunar south pole. However, the agency is open to contributing the Viper rover in its current form to a qualified partner. So from July 17 to August 1, NASA accepted expressions of interest from the broader community for utilising the Viper rover. The current RFI aims to gather detailed proposals from interested parties on how they would deploy Viper with minimum or no cost to the government. Now, this opportunity is available to US organisations and industry, while NASA plans to assess international interest through separate channels. NASA appreciates the responses received and looks forward to learning more about how potential partners plan to leverage Viper to achieve scientific and exploration goals, according to Nicola Fox, the Associate Administrator for the Science Mission Directorate at NASA headquarters in Washington. She says, "We aim to maximise the use of the engineering, technology and expertise developed for Viper to advance our understanding of the moon. Partnering on the mission would allow us to do so without affecting our future schedule of commercial lunar deliveries, ensuring continued progress in lunar science and exploration for all. Future deliveries to the lunar surface through NASA's Commercial Lunar Payload Service program, as well as instruments on crewed missions, will continue the agency's efforts to assess volatiles across the South Pole region. The request for information is available online and will remain open until Monday, the 2nd of September. Still on NASA, and their scientific balloon program has begun its annual fall campaign at the agency's launch facility in Fort Sumner, New Mexico. From mid-August through to mid-October, 8 balloons are scheduled to be launched, carrying scientific experiments and technology demonstrations. These flights will support 16 missions across various fields, including astrophysics, heliophysics, and atmospheric research. A notable return to the fall lineup is the EXCITE program, the Exoplanet Climate Infrared Telescope mission, led by principal investigator Peter Nagler from NASA's Goddard Space Flight Center in Greenbelt, Maryland. EXCITE is an astronomical telescope designed to study the atmospheric properties of Jupiter-like exoplanets from near space, and it was delayed due to the 2023 campaign due to weather conditions. Additionally, 8 piggyback missions will accompany the flights to further science and technology development. If you want more information on NASA's scientific balloon program, visit nasa.gov/scientific balloons. Supermassive black holes are located at the centres of large galaxies, including our own. And when these black holes are actively consuming matter, they emit a significant amount of light and are referred to as active galactic nuclei, AGNs. However, observing the details of AGNs is challenging due to the large clouds of gas that obstruct our view. Bring in the James Webb Space Telescope, which was specifically designed to handle these kinds of challenges. Recent research published in the monthly notices of the Royal Astronomical Society showcases James Webb Space Telescope observations of a supermassive black hole in a galaxy approximately 70 million light-years away. The telescope detected polar dust surrounding the SMBH, situated beyond the expected torus of dust that directly accretes from the black hole, known as the accretion disk. Interestingly, this polar dust is heated not by radiation from the accretion disk, but by energetic shock waves generated by relativistic jets. The study, titled Dust Beyond the Torus, revealing the mid-infrared heart of local SAFET ES0428-G14 with James Webb Space Telescope and MIRI, was led by Huda Haidar, a PhD student at Newcastle University in the UK. Haidar and her co-researchers are part of GATOS, Galactic Active Torus and Outflow Survey, an international team using the James Webb Space Telescope to investigate the mysteries of active galactic nuclei. While this is James Webb Space Telescope's first observation of galaxy ES0428G14, astronomers have been studying this SAFET galaxy, known for its high luminosity, for decades, using various telescopes, including the ALMA and Hubble telescopes, with their data contributing to this particular line of research. One of the main challenges in observing AGNs, including this one, is the presence of thick, extensive clouds of dust and gas that eventually feed the black hole, obscuring our view. The James Webb Space Telescope mission is to penetrate such dust and provide a clearer view of these hidden regions. The telescope revealed extended mid-infrared emissions stretching up to 650 light-years from the AGN. The polar dust's structure aligns with a radio jet emitted by the AGN, but it's perpendicular to a molecular gas lane feeding and obscuring the AGN, providing crucial evidence for the existence of polar dust. The morphology of this dust closely resembles gas ionised by the AGN. However, the new James Webb Space Telescope images show that much of the polar dust emission is extending along the jet's paths, indicating that the jets, rather than the radiation from the AGN, are primarily responsible for heating and shaping the dust. The temperature differences between the accretion dust and the polar dust offer clues about the distinct heating mechanisms within the AGN, with jet-induced shocks likely causing the heat disparities. About 4 years ago, a team of scientists announced the discovery of phosphine in the atmosphere of Venus. The popular press latched on to the story quickly because phosphine is considered a biomarker, and news ran rife that there could be life on Venus. However, others in the scientific community were sceptical, and eventually the claims were debunked and the story faded away. Until now, 4 years later, and the same team has used a new tool to examine the atmosphere of Venus and have, yet again, announced that they have found phosphine. So, what does that mean this time around? I discussed the latest development with Professor Fred Watson from the Space Nuts podcast.
So once again, this team has pointed their telescope at the planet Venus, but this time they have a new receiver on the telescope. And that apparently is the game changer in this work. It's certainly giving them a good deal more confidence in the results that are coming out of it, and much more of the data themselves. Basically, the bottom line is that in each of the three observing campaigns they've done with the James Clerk Maxwell telescope, they've got 140 times more data than they did with the original detection. So that's why they are much more confident in their results. This is a quote from Dave Clements, who's a reader in astrophysics at Imperial College in London and one of the team members. What we've got so far indicates that we once again have phosphine detections, and so that's it's a bold thing to do, to go back to your original target, knowing perhaps that you've got a better instrument, and have another look, and it looks as though they are much more confident. But there's also but wait, there's more story, because there is more to this. There is another observing team which is working on a different part of the microwave spectrum, and they think they've detected the gas ammonia, and that apparently is basically an even bigger puzzle. So, quoting Dave Clements again, he said, "That is arguably more significant than the discovery of phosphine. We're a long way from saying this," but he's saying it anyway. "We're a long way from saying this, but if there is life on Venus producing phosphine, we have no idea why it's producing it. However, if there is life on Venus producing ammonia, we do have an idea why it might want to breathe ammonia." And that is the interesting part of this. And just to elaborate again, another comment from Dave Clements, phosphine has been discovered in the atmosphere of Saturn, but that's not unexpected because Saturn is a gas giant, and there's an awful lot of hydrogen in its atmosphere. So any hydrogen-based compounds like phosphine or ammonia are what dominate there. But the same is not true of rocky planets like our own, and Venus and Mars. And that's why, the possible detection of these hydrogen-based compounds, phosphine and ammonia, are so unexpected on Venus.
Well, it does open up a can of worms, and it could be worms, I'm not sure. But what are the odds of it being life? I know they say they're a long way from saying it is, but it could be. Or well, I suppose the alternative question: what else could be causing the existence of phosphine and ammonia?
That's the right way to look at it. He's very, Dave Clements is certainly talking the talk and giving us some very good quotes here. Phosphine and ammonia have both been suggested as biomarkers, including on exoplanets. So finding them in the atmosphere of Venus is interesting on that basis as well. When we published the phosphine findings in 2020, quite understandably, that was a surprise. And so he makes the point that other instruments have not actually made that detection. And they include the Venus Express spacecraft, which is an ESA spacecraft in orbit around Venus. They include and something called the IRTF, which is a NASA facility, again on Hawaii, not actually very far from the James Clerk Maxwell Telescope, NASA Infrared Telescope facility. And observations made with actually an observatory that another of my friends has worked on, SOFIA, which was the airborne NASA observatory, on that 747 SP with a big hole in the back of it. That's now no longer flying. But that, when it was, had also obviously observed Venus, and they didn't find these phosphine findings. So there's a number of different investigations that have not turned up the gas phosphine. And I am getting to the answer to your question in a minute, Andrew. I'm working round to it. But they've ruled out one of the things that was suggested as being a contaminant when that first lot of phosphine observations were released, and that was sulfur dioxide. And that is basically ruled out now by the Atacama Large Millimeter Submillimeter Array, ALMA. But the key thing here, and again, I'm going to quote Dave Clements, it turns out that all our observations that detected phosphine were taken as the atmosphere of Venus moved from night into day. And all the observations that didn't find phosphine were taken as the atmosphere moved from day to night. And the suggestion is that the ultraviolet light from the sun actually breaks up these molecules as it moves from day into night. So, if you take them at the end of the day, the molecules have all gone because the sun's basically baked it out, as Dave Clements puts it. All phosphine is baked out, and that's why you don't see it.
Okay.
Yeah. So that suggests that the phosphine observations might be real, and they might be sort of being replenished, if I can put it that way. Because if you've got phosphine that at the end of the day isn't there, it's been baked out, but at the beginning of the day it is there, it suggests that something is forming phosphine, and maybe that is an indicator of life.
Yeah, you've got to wonder what kind of life that could be. And it would be residing in the upper atmosphere because it's too hot for anything down on the planet.
That's correct. And there's nasty things as well. There's all the sulfuric acid at lower levels in the, down in the droplets cloud, the clouds of Venus further down. So look, what they're suggesting, and this now is a quote from, actually, once again, from Dave Clements. I thought we were going to get another voice, but ammonia. Actually, let me quote Jade Greaves is Professor of Astronomy at Cardiff University, and actually, I think she's the leader of the team. She says the exciting thing behind this will be if it's some kind of microbial life making the ammonia, because that will be a neat way for it to regulate its own environment. It's really interesting that they are so confident with these observations. They're actually trying to look at what mechanisms living organisms might be using to create the phosphine or the ammonia. So I think they'd put it at 50-50. I'm just reading between the lines here. Myself, I'd put it lower. I think that maybe, we've barked up this tree so many times, Andrew, looking for rock-solid biomarkers, and they're very, very difficult to find. Even if you find something that you think is only caused by living organisms, there's probably always going to be another chemical way, purely chemical way, that you might form it, and that might not have been found yet.
And one more thing before we wrap it up. ESA's Jupiter Icy Moon Explorer, otherwise known as JUICE, is set to make a critical return to Earth around August 19 and 20. Flight controllers will guide the spacecraft in a groundbreaking manoeuvre, flying past the Moon and then the Earth. The double gravity assist, a world-first lunar Earth flyby, will act as a braking manoeuvre, adjusting JUICE's speed and direction for its journey to Jupiter via Venus. Yep, it's got to go in before it can go out, but apparently that's a shortcut. The operation is intricate, as even a minor error could derail the whole thing. Launched in April last year, JUICE's upcoming lunar Earth flyby marks the first major step in its complex voyage through the solar system. During the flyby, Earth will curve JUICE's trajectory, slowing it down and setting it on course for a Venus flyby in August of next year. It's slow, isn't it, for a fast trip? From there, the spacecraft will gain additional energy boosts, first from Venus and then from 2 subsequent flybys of Earth. It's complicated, but it works. We hope. Fingers crossed. Well, that brings us to the end of this episode of Astronomy Daily. Don't forget to visit us online at spacenutspodcast.com or spacenuts.io, where you can sign up for the Astronomy Daily newsletter. And the next edition of Astronomy Daily coming up tomorrow. And Steve will be back with Hallie later in the week. From me, Andrew Dunkley, thanks for your company. This has been Astronomy Daily.
Astronomy Daily, the podcast, with your host, Andrew Dunkley.